previous section has got lots of little things that you're going to kind of discover as you do the questions. But we're now moving on to something that has a very similar name. It's called related rates. Now, related rates are questions where all the variables in the formula that you see, like the X, the Y, the R, the A, the V, all the other letters, all the other variables, they are all dependent on another variable, T, usually called time. So we tend to use related rates in stories where you've got an object, but it keeps changing through time, right? So it gets bigger or smaller as time goes by. So when you differentiate a formula using this related rates, you always need to incorporate the variable T. So for example, that is the equation of a circle, center of the origin, radius 9. Can you imagine the X and Y values start moving as time goes by, so the circle starts getting distorted? We're going to learn how to differentiate that, and it's not that hard. It's very like chain rule, really. You differentiate this guy, you get 2x dx by dt. Y squared, you get 2y dy by dt. And if you differentiate a number, you get 0. I think the major difference here is that if this was implicit, right? If this was implicit differentiation, wouldn't this be 2x and that's all? Wouldn't this be 2y, but it'd have a dy by dx here, and wouldn't that be a 0? So it's not the same as implicit differentiation, but it doesn't have a very similar look to it, right? What we do in related rate questions is that all the variables, including the x, are functions of time, right? They all are related to time. They change through it. So I'll show you how the process works. One of the classic questions is that you are given an equation. Oops, let me try that again. If you're interested, that happens to be an ellipse. And question A is asking us to find dx by dt. And they tell you some other things. They tell us that dy by dt is a quarter, and that x is 3, and that y is 2. Now, that's the typical question. You'll have an equation, you'll have a guy that you're trying to find, and they will tell you what the other variables are. So first thing you're going to do is start with the original equation, which is this guy. Step 1, you're going to differentiate with respect to t. So let's see what that looks like. If you differentiate 4x squared, normally you get 8x. But in these questions, you also get an extra dx by dt, because x is a function of time. And if you differentiate 16y squared, you treat it the same way you would treat 4x squared. You multiply by the power, and you reduce it by 1. And then you remember to finish with the dy by dt. And if you differentiate 100, you still get 0. Are you comfortable with what we did here? Differentiate, differentiate, differentiate. The difference is that you have a little dx by dt or a little dy by dt. So far, so good. Step 1 is differentiate. The second step is substitute. So in this question, we are told the x is 3. So that's 8 times 3. I don't know what dx by dt is because I'm being asked to find it. Plus 32y. I know what dy by dt is. And it's equal to 0. So you will replace all the variables by whatever value you were told they were equal to. And then your final step is solve. Well, solve for whatever you've been asked to find. So in this case, solve by finding dx by dt. Any ideas what the next line of working might look like? What do you think I'm going to do next to this mess here?
Subtract the 32 times 2, the 1/4,
You're right, I would.
and then divide by the 24.
Agreed. I'm going to do exactly what you said. I'm just going to put in an extra line. I'm making that 24 and making that 16, right? And then I'll do what you said. So subtract 16 from both sides. So we're using the as long as you do it to both sides is okay rule. And this can be divided by 8, so what's that, negative 2/3. So the rate at which the x coordinate is changing through time is negative 2/3. So the x coordinate is getting smaller by roughly negative 2/3 every second. And basically that's it. So you're going to differentiate with respect to t. You're going to substitute in all the values that you know, and then you're going to solve for the missing term, whatever it is you've been asked to find. A little bit different. Let's find another one. Let's look at question 2. The equation that we're going to be working with is this one. If you're interested, this is the surface of a sphere. And you're told, so these are things you know the value for. You're being told that the x coordinate is changing at the rate of 9 units a second. That the y coordinate is changing at 5 units a second. And you're being told that x, y, and z, that's a nice short way of writing it, happens to be the point 2, 2, 1. And you are being asked to find what the value of dz by dt is. So in other words, how is the z coordinate changing in this story? So basically you've got the surface of a sphere and it's being changed, right? The x's are getting bigger, so is the y's, but they're not quite getting bigger the same way. So this shape is morphing into some kind of cylinder, I would say. And we're being asked to find this guy. So step 1 is differentiate. So x squared gets you 2x dx by dt. Y squared gets you 2y dy by dt. Z squared gets you 2z dz by dt. And if you differentiate a number like 9, you get 0. You comfortable with that line? Right? Everybody gets differentiated with respect to time now, right? And everybody is treated the same way, right? X is no different than Z. Now I'm going to plug in all the guys we know. 2 times, by the way, X is 2, Y is 2, and Z is 1, right? 2 times 2 times 9. 2 times 2 times 5. 2 times 1 times dz by dt is equal to 0. Do you notice that there's only one guy missing? And that's the guy we're going to try and find the value of, right? Everything else is a number. So make that 36, make that 20, make that 2. And now we're trying to solve an equation. And in this equation, that's the guy we're trying to find the value of. Okay. As long as you do it to both sides, it's okay, Ro. Great. So what could I do to both sides?
Subtract the 36 and 20.
And if you do that together, you end up with, I think, -56, correct. And to finish then, what should I do to both sides?
Divide by 2.
And so your answer is that the Z coordinate is shrinking. Oh. So this is me just visualizing it. You got a sphere, and the X is getting bigger and the Y is getting bigger, but the Z is shrinking. So that thing is getting morphed, changed into that shape. Can you see you could use that in animation? You know, if you want to take something and have it, change through time, you could do a bubble. I don't know why a bubble would change it in that, but you could do that. We kind of coolly do that, actually. So far, so good. Yeah. Okay. So question 3, 4, 5, the ones that are coming next, the formula is going to be one that you should know. And if you don't, you can always look it up. So question 3 is dealing with the area of a circle. So they didn't tell me the area of the circle, but I know its formula. So you start with the formula. And the question's a little bit different. It says, find that guy. And it says, in terms of dr by dt. So in question A, you're just being asked to find what dA by dt is in terms of dr by dt. Right, I guess I could write it down again. Here's this guy. You differentiate this guy with respect to t, and if you differentiate this guy with respect to t, pi is just like a number, so you get 2 pi r dr by dt. And essentially, didn't they just tell me to do step 1? Now, part B goes on and they tell you things. So let's see what you're told. You're told that the radius of the oil spill increases. So dr by dt, the circle, is increasing with 2. And you're told that the radius was 38. And we're being asked to find that guy. Okay, so dA by dt is 2 times pi times a radius of 38 times 2, and I wouldn't even say that's solving an equation because it's kind of set up. And it's okay to leave your answer like that. And so don't turn it into a decimal. If they want a decimal, they will say to 2 decimal places kind of thing, right? So if you don't see, give the answer to 2 decimal places, 4 decimal places, then assume that they want an exact answer. So it's okay you have 5 square root of 2 as an answer, right? That's okay if that happens. Let's do a volume. Does anyone know the formula for the volume of a sphere? Anybody?
4 divided by 3 pi r cubed.
Well done. Yeah. Now, if you don't know it, won't you go looking for it? Right? You just go online and say volume of the sphere, you'd find it. Now, in this question here, let's suppose I tell you that the radius of this thing is changing at 5 meters per second. So that's a fast growing sphere, right? It's a boom, explode thing, right? And I tell you that radius was 10. I guess it would be in meters, right? And I said to you, find the rate at which the volume is increasing. So that's your package. Let's see how we can do it. First thing I'm going to do, step one, is differentiate with respect to t. So that guy. Multiply by the power. Reduce the power by 1. Remember to finish with that little guy. Plug in everybody that we know. And so it's 4 pi 10 squared times 5. That's 100. That's 20. So that would be 2000 pi. And it's a volume, so it's cubic meters per second. You don't need to worry about the units because WebAssign normally gives you them. So you would just be typing, no, 2000. You would be just typing that guy. So this is modeling a sphere turning into a bigger sphere. And when this is a radius of 10, right, when it's growing at radius of 10, in the next second, its volume is going to increase by roughly about 6,000 plus cubic meters. Aren't we basically modeling some kind of explosion, like a little thing becoming a big thing really fast? And so what related rates are very good for modeling things that are changing through time, right? Things that are getting bigger or even smaller. How about this rather puzzling question? This is version question 4, where we have each side of a square is increasing at the rate of 8 centimeters per second. At what rate is the area increasing? Ah, this is sneaky. When the area of the square is 25 square centimeters. Well, I need a formula to work with. So there's a bad picture of a square. Might as well call the sides x. So the formula I'm going to work with here is the area of a square. Which creates that. Didn't tell me the formula, like they didn't tell me the formula for an area of a circle, and they didn't tell me the formula for the volume of a cone. I had to figure it out, right? So not only did I have to figure out, then I have to decide what letter to use, right? So I've decided an X. If you don't know a letter, pick X. That's cool. Now, differentiate with respect to t is not a biggie. And let's just remind you what we're told. We were told that the rate at which the side is increasing is 8. And we were told that the area was 25 square centimeters. And we're being asked to find dA by dt. Well, we hit a bit of a snag here. I don't know X. Well, actually, I do know X, it's just hidden. If the area of the square is 25, don't I know X? What's X if the area is 25?
5.
Do you see that they made the X a little bit less obvious than they have in the previous questions, right? Normally they just tell you X is 2, R is 40, right? They just tell you, right? You don't need to look for it. It's in the question, you just read it. But in this case, nah, a little bit sneaky, right? But telling me the area doesn't not really indirectly tell me the X as well. So the answer I'm going to get here is 80, and I guess the units is square centimeters per second. So this square is getting bigger, right? It's a small square, it's becoming a bigger square. And when the area was 25, it's about to get bigger. How much bigger is it going to get in the next second? Its area is going to increase by that amount. Any questions so far? Are we good? Right, let's go back to a sphere again. They're good questions to do. I'll make one up. Right, there's our starting formula. Let's suppose I tell you that the volume is increasing at 100 cubic meters a second, right? So you're told that. And let's say I tell you that R is 5. And I ask you to find what's the rate at which the radius is increasing. Now, there are going to be a lot of similarities between what I did in the previous question and what I'm about to do. Right, of course, I'm going to begin by differentiating with respect to t, multiply by the power, reduce the power by 1, and put in dr by dt, right? That's exactly what we did last time. I'm going to put in the numbers, but this time I know this guy is 100. This is 4, this is pi. I know this guy is 5 squared, and I have dr by dt. That's 25. 25 times 4 gets me 100 pi. Okay, that's where we are right now. I need to find dr by dt. Essentially, I'm solving an equation, right? So as long as you do it to both sides, it's okay, Ro. What should I do to both sides to get dr by dt?
Divide by 100 pi.
Now, since we're working on exact values, which means don't turn it into a decimal, I could do some style points on this, couldn't I? This fraction could be made a little bit prettier, and you're expected to do that. So what would you simplify this thing into?
1 over pi.
So the radius is not increasing a lot here, is it? It's about a third, right? A little bit more than a third. Not much. And we're finished. I guess I should put the units in. In this case, it would be what? Meters per second. I think I'm picking up good vibes here. Wish I had more pictures to see. Are we good? Right, let's kind of, here's a formula. Differentiate it with t. Plug in what you know. Find whatever it is that's left over that you've been asked to find. So let's move on to 7. The length of a rectangle. So I'm a visual person, so I'm going to draw this thing. The length of a rectangle, there you go, is increasing at the rate of 7 centimeters a second. So you've just told me that dl by dt is 7. Right? So that's the things I'm told. Okay. Its width, okay, I'll call you that W, is increasing at the rate of 3. Okay, I got that. You're told also that the length is 7 and that the width is 5. And we're being asked to find that guy. Now down here they said the area, right? dA by dt. That tells me that the formula I'm going to be looking at is those two guys multiplied. Agreed? Now things get a little bit different. This is the first time we've ever needed to deal with two variables multiplied together. And these two variables are considered equally to be functions of t, right? They're variables involving t. So when I differentiate this guy, he's easy. But when I differentiate this guy, I have got to think of this as a product rule. Does that make sense? L and W are two things multiplied together, and I want to differentiate two things that are multiplied together. So it's going to be an F dash G plus an F of a G dash. So let's see what we get. If you differentiate L with respect to T, you get that. And if you leave this guy alone, you get W. Plus you leave the first one alone and you differentiate this guy. Are you comfortable with that line of work? Does it make sense? Right. Differentiate with T, had to do a product rule. First guy's derivative, leave the second one alone, plus leave the first one alone, differentiate the second guy, and the second guy is called W, by the way. So should be his real name in. Now let's put in what we know. We know this guy is 7. We know this guy is 5. We know this guy. Wow, okay. This guy is also 7, but for a different reason. And this guy is 3. And so I get 35, and I get that guy, I get 56. And what were the units? Centimeters squared per second. Are we good? Right. Now I want to change this question slightly. I'm going to have the same rectangle, pretty much everything else the same with one change. The length is getting bigger at the rate of 7 centimeters a second, right? That's the units. But the width is getting smaller. In other words, the width is shrinking. And that is a negative number. Does it make sense that if the rate is negative, it means that the width is getting smaller, right? It's going down the way. Now, if you do all these calculations, won't the only difference be that guy there? And so you end up with not that number, but you end up with 14. Do you see in that second situation that this rectangle is still getting an increase in area, agreed? But isn't it less than it would have been if both of them were getting bigger? But that kind of makes sense. Can you imagine that if you started with this one and both of them got bigger, but if you started with this one and one of them got bigger, but the other got a little bit smaller, yeah, it's a bigger area, right? But would you also agree it's not as big as both of them increasing? So that kind of makes sense. Is it possible for this answer to be negative? Could you have the rate of change of area with time a negative number? Do you think that's possible?
Yeah.
Yeah. Doesn't it mean that the rectangle is just shrinking in size? Right? Couldn't you have a sphere that's actually collapsing? You know, like becoming a black hole or something, right? Shrinking rather than getting bigger. Right? Yeah. All rates are allowed to be positive, negative, and I guess zero's doable. Happens. We're still good, guys? Moving on to a cylindrical tank then. A cylindrical tank with a radius of 7. Okay, now that is fixed. There's my tank. Is being filled with water. Oh, okay, so imagine water coming in and it's water's coming in. And the rate at which the volume is increasing, which is what the water is doing, is 2 cubic meters, right, per minute. So, okay, so changing the time in minutes. They're asking us to find how high the h by dt is, find the rate of increase in the height. Okay, so I'm told this and I'm asked to find that. Okay, I guess it's one of those things you have to go hunting on the internet if you forgot. But what is the volume for a cylinder, a typical cylinder? Any takers?
Is it pi r squared h?
You nailed it. Now, in this story, since the radius never changes, right? It's a fixed tin can, right? The can's not changing, it's just the water you're pouring into it that's changing, I guess. This particular cylinder, just this one, isn't that going to be pi times 7 squared times h, which means it's what, 49 pi h. You see, the formula for this one unique cylinder is a little bit different than just the general, you know, anything cylinder. Now, that's the formula that we are now going to differentiate with respect to t. And in a lot of ways, this question is very easy to do. Would you agree? Differentiate that, you get this guy, multiple of this one, multiple of that guy. And now we'll put in what we know and see what we're being asked to find. That's 2, 49 pi dh by dt. And yep, that's the guy I want to find. So how about divide by a really ugly fraction? And that is the answer. An exact value, don't need to turn into a decimal. Are we good with that one? Okay. How do you do this one? How do you do this one? I'm going to do 9, or at least a version of 9. Problem with 9 is that there's a lot of writing, and I don't want to write it down. So I'm just going to tell you the story. And as I'm telling you the story, I'll draw the picture. So a plane is flying horizontally at the altitude of 2 miles. So that distance from here to here, there's my little plane, is 2 miles. Here's the ground. And the aircraft's flying this way. So I'm going to call that X. And the speed of the aircraft is 490 miles per hour. Then it says, find the rate at which the distance from the plane to the station. So here is a station, a little radar station. Looks like that. Yeah. Can you tell why I failed art class? Right. That's a radar. And it gets to there. And we are being asked to find the rate at which the distance from the plane. So the plane is now here because it's flown a little bit. And we're wanting to find that distance, right? And we're being asked to find it. I need to give a letter of that. It doesn't really matter which letter of the alphabet. Agreed? I decided to call that X because I like X. Since I like Y, why don't I call that guy Y? Right? It's got nothing to do with the X and Y axis, right? It's just got to call it something. Couldn't I called it P and Q if I felt like it, or Z and W or whatever other letters, right? They're just placeholders, X and Y. And we're being asked to find the rate, let's see, find the rate at which the distance from the plane. So we're being asked to find dy by dt. And we're being asked to do that at a specific point in time. We have to do it when total distance is 5 miles away from the station. So we have to do it when y equals 5. So I'm told that, I'm being asked to find that, and I'm told that, right? So that's all the pieces. I'm going to make that an obvious right angle triangle. Can you see it? Vertical meets horizontal. I need an equation connecting the X and the Y together. Does anybody know of an equation involving right angled triangles that might be helpful in getting something that uses these variables?
The 2 squared plus x squared equals y squared.
Okay. It's kind of what I heard. You agree? Pythagoras essentially, right? 2 squared plus x squared equals y squared. Looks good to me. In this question, your starting point is your optimization equation, right? It's just a fancy name for the equation you're going to use. Now, I would probably rewrite that while we're at it, like that, okay? You need to have an equation connecting all the variables in the story. Now, once I've done that, step 1 kicks in. Differentiate x squared, you get 2x dx by dt. That guy, when you differentiate, gets you 0. And differentiate this y, you get 2y dy by dt, right? At this point, I am going to plug in what we know. Well, I have 2 times, I don't know x, dx by dt, 490. I'm not going to add 0, it doesn't matter. 2 times 5, and I want to find dy by dt. And this has happened before. Remember the square where we didn't know x? Well, we do know it. It's just hidden. If I know that y is 5, shouldn't I be able to find out what x is equal to when y is 5? How can I find out the value of x? So how can I find the value of x when I know that y equals 5? Help me out here. How will I do that?
The Pythagorean theorem again.
Yeah. So can't I just use that guy? And I'm assuming, because it's distance, that we're talking a positive number. So in here, it's the square root of 21. Are you comfortable where the x came from? Right? Basically 2, 5, what's that guy? That guy ends up being a rather ugly square root of 21. Well, we're getting there. Do they want an exact value? Let's find out. Oh, good. Round off your answer to the nearest whole number, right? That's going to make life a little bit easier. I'm still going to keep it together for a little bit longer before I start going too near my calculator. So 2 times 490. makes this guy 980 square root of 21s is equal to 10 times dy by dt. And so if I wanted to find, which I do, what's the rate of change of this guy, shouldn't I take that fella and divide them by 10? And then I could do that in my calculator. 98, yeah, that's 98, times the square root of 21, and to the nearest whole number, I get 449. And let's check that. And we are right. Can you see in these later questions, we've got a lot more work to do, right? Less things are given us to us on a plate. We have to figure out what the equation is. That's a biggie, because if you don't know that, you can't really get started. And very often, there's going to be a guy that looks like he's missing, but they tell you enough to let you figure out who he really is, right? So they won't just say, oh, X is the square root of 21, you know, not, you know, they'll make life a little bit trickier for you. Time for one more, maybe? Yeah, last one for today. Okay, at noon, ship A is 170 kilometers west of B. So there's starting point. And that's 170. And that's going to be where ship A starts, it's where ship B starts. Ship A is sailing east. Yikes. Okay, so ship A is sailing east. I'll call that X. And it's sailing east at the speed of 30 kilometers an hour. So you've just told me that dx by dt is 30. That's what east looks like. And ship B is sailing north. Okay, so you're going north. And I'm going to call that guy Y. And you're telling me that it's sailing north at the rate of 25 kilometers per hour. Okay. How fast? Oh, okay. How fast is the difference between them? After 4 hours. They phrase it as 4 a.m. but 4 p.m. That's still 4 hours. Now this picture is not as obvious as how I'm going to connect X and Y together, but I'm being asked to find that guy there, right? That distance there. And I'm going to call that Z, because I want to. And I'm going to build another picture, a little bit different. It's going to be a right angle, so basically this piece of the picture. And that guy are pretty obvious. What's not so obvious is what this side is. I know that guy is X, which it is, but how much is that distance? Because that's not 170, and that distance there, which is the bottom bit, isn't X either. So what is that distance? If from the start to the finish is 170, and from there to there is X, what is from here to the end?
I mean, 170 minus X, but you still don't know X.
Right, 170 minus X, I agree. What was it you said about you still haven't, what?
We still don't know X, so we don't know like the actual number of the problem.
Oh, we don't know the number, that's right. But right now, that's actually what I want. I don't want numbers for X yet. That's going to come later, right? It's going to be in the told side. Right now, what that's going to do is it's going to allow me to get the optimization equation, right? You know, this guy here. Now, it's a right angle triangle. So won't 170 take away X squared plus y squared equal z squared. You agree? Pythagoras. That guy squared plus that guy squared equals z squared. This ugly expression is the optimization equation, right? This is the guy that we're going to differentiate. Are we still good, guys? Right, now I'm going to differentiate it, just like we did all the others. This thing here is going to be a pain in the butt, but we'll figure it out in a minute. Let's do the two easy ones. If you differentiate this guy, you get 2z dz by dt. Check. If you want to do this guy, you get 2y dy by dt. First time we've had to deal with an expression like this. Okay. Any takers? Anybody want to have a shot at differentiating this expression with respect to t?
Should it be 2 times the inside function times -1?
One extra little bit. Everything's perfect except
The
That's
dx
one
over d of 2.
Yep, that's it. So it's 2 times, write it again because it's really messy, that guy with a minus dx by dt plus 2 times that guy times 2 times this guy. And I just realized we ran out of time. So I'm going to keep that piece of paper for tomorrow and we will continue from this line. But essentially, and someone, I think it was Carter, might have been Harmon, who said, but we still don't know X. You're right, we still don't know quite a few things, right? But they are hidden in the story. So we are going to be eventually finding the value for X, for Y, and for Z. At least we know these two, right? But we don't know what number X is, Y is, and Z. But once I do know what these are, won't we then be able to solve for dz by dt? So when you come back tomorrow, we're going to kind of figure out how to get these missing X, Y, and Z, guys. And that will be us done. So make sure you give your last name. And bye-bye for now.
Thank you.
You're welcome. Any questions? Jason, you good?
No, I have a question. I just
Yes.
trying to
Please.
find it in the website. Okay, yeah. So for 3.7 question, the last bit of the first question. How do you tell? Like, I'm not really sure how to do the last bit. Like, where you tell if the speed is increasing or decreasing.
Okay, let me go back to that one. Which question are we on? 3.7? 3.8?
Yes, 3.7 and the bottom of question 1.
Oh, the bottom of question 1. Increasing or decreasing? Is that the question you said?
Yeah.
All right, let's find that question. So I've got your specific one. Okay. And it's question 1 right at the bottom, you said.
Yeah.
Right, increasing and decreasing, or is it speeding up and slowing down? Which is it?
I think speeding up and slowing down. Like,
okay. So when you're doing a question, actually, it looks like question 1's done. No, it isn't. There's a bit at the end I missed. Okay. These two, we did it twice, but there's a lot involved in this. So let me kind of show you the gist of what's going on. Right. Okay, what happened there? My windows are just playing up. There we go. Right. You've already found a number line with a velocity information, right? It goes 0, 1, 2, 3, 4, 5, and 6. And you've got another one which had the information about the acceleration in it, right? 0, 1, 2, 3, 4, 5, and 6. And in the velocity one, let me get the numbers so I can use them. It was 2 and 4. So at 2, the velocity was 0, and at 4, the velocity was 0, right? And oh, darn it, I don't know right now. Let me check it. I believe it was positive, then it was negative, and then it was positive. Does that sound right?
Yeah.
Right, and then the acceleration, you found out that the acceleration was 0 at, was it 3, I think? And the acceleration would be what formula? 6t take away 18. So the acceleration was negative here and positive here, right? So if these are the correct velocity and acceleration graphs, you kind of need these to do the speeding up and slowing down. But it's helpful, in fact, kind of vital that you put them together. Now, once you've got them one above the other, do invisible dotted lines through anybody, either velocity or acceleration, doesn't matter, which is 0, right? So I've got region A, region B, region C, and region D. I have essentially got 4 regions. In those regions, it's either going to speed up or slow down. For instance, in this region, it's 0 to 2. In this region, it's 4 to 6. This region is what, from 3 to 4, and this region is from 2 to 3, right? That's what they look like as intervals. If they're both the same, is it speeding up or slowing down?
Speeding up.
So it's speeding up here because they're both negative, and it's speeding up here because they're both positive. And if they're one of each, it's slowing down. So far, so good?
Yeah.
So you want to know when it's speeding up. That's 2 regions of time. It's speeding up in the 2 to 3 second mark, and then from the 4 to 6 second mark. And when's it slowing down? Well, it's slowing down from 0 to 2 and from 3 to 4. And you could argue about that being a square bracket and that one being square bracket. I'll just call them round. That's how you get the answer.
Okay.
Now, if it doesn't finish at 6, then the only difference is that this is going to be infinity.